A slit of width B is illuminated by white light. What value of B will the first minimum of red light be at theta equal to 15 degrees? So use this formula, B sine theta equal to n lambda. This is similar to diffraction grating, but there is slight difference for single slit. For single slit, we call this as B. Okay. So, but for the first minima, this is the first minima. This is the first minima. So from here to here, this is what we call the theta. This angle is theta. All right. So using this formula, B is opening, slit opening. Theta is the first order minima. For this case, the n will be 1. Okay. This is not the same as diffraction grating. Please do not mix up. The diffraction grating is d sine theta equal to n lambda, and this n lambda is for constructive interference, is for maxima. But for this one, if you want to find the first minima, you must use n equals to 1. All right, so you get this as the answer. Okay, now we have some new terms here that some of you may not understand. For example, like first side secondary diffraction maximum. What is that? Let's look at the second question. What is a wavelength whose first side of diffraction maximum is at 15 degree coincide with the first minimum of the red light? It means this one. Okay. So now this is the first secondary maxima. So this is a central maxima. This is the central maxima. This is the first secondary maxima. This is the first minima. All right. So for maxima, you need to use this. You need to use B sine theta equal to n plus half lambda. This is exactly opposite the formula for diffraction grating. Please do not forget. So for first secondary maxima, you use n equals to 1. All right. Now, so B sine theta equal to 1.5 lambda. Just sub n is 1 inside. So you sub the information, you can get this is the answer.